You've probably heard the hype, right? This idea of a single genius AI that can write and fix all our software. But what if that whole idea is wrong? What if the future of AI coding isn't a lone wolf, but a whole collaborative team? Today, we're diving into Agyn, a system that's doing just that, building an AI dream team for coding. So, let's just start with the big question that's been driving so much of this research. Can one AI, no matter how powerful, really handle everything? I mean, from understanding a super tricky bug, to navigating a massive code base, to writing a perfect fix, that's a huge ask. And well, it's starting to look like the answer is probably not. And you can really see the two different ways of thinking laid out here. On one side, you have the lone AI agent, just trying to juggle everything at once and getting totally overwhelmed. But on the other, you have the human team model. You've got specialized roles, you've got people talking to each other, you've got quality control. It's really the difference between a one-man band trying to play every instrument and a full orchestra. So let's dig into that first approach, the lone AI coder. For a long time, this was kind of the holy grail, to create one single brilliant AI that could tackle any coding challenge you throw at it. But as we're seeing more and more, that approach is really starting to hit a wall. Here's the root of the problem. A single AI just has to wear too many hats. It's got to be a detective, then an architect, then the coder, and finally the quality tester, all at the same time. This just forces a one-size-fits-all approach onto a process that, in reality, is super specialized. Yeah, there's actually a name for this. It's called a monolithic process. Just try to imagine one person on a huge project being the project manager, the main researcher, the coder, and the senior code reviewer. It's not just inefficient, it's pretty much a recipe for burnout and mistakes. Okay, so that's the problem. And this is where Agyn just flips the script. Instead of asking, how can we build a smarter lone coder, the researchers behind it asked a totally different question. What if we built a smarter team? All right, so let's meet the crew. First up, you've got the manager. Think of this agent as the team lead or the conductor of the orchestra. It's not in the weeds writing code. Instead, it's directing the workflow, pulling all the information together and making those crucial high-level decisions about what to do next. Then there's the researcher. This agent is basically the Sherlock Holmes of the team. Its whole job is to dive deep into the code, investigate the bug, figure out the root cause, and then create a really clear, detailed plan for how to fix it. And of course, you need someone to actually get their hands dirty. That's the engineer. This is the agent that takes the plan from the researcher and makes it happen, writing the code, running tests, and tweaking things over and over until the problem is actually solved. And what's a software team without quality control? That's where the reviewer comes in. This agent is the gatekeeper. It carefully inspects the engineer's code, gives feedback, and makes sure that only high-quality work gets the green light. So, why does this team setup work so much better? Well, first, everyone has a clear job to do. That separation of responsibilities is key. But what's really brilliant is that you can use different AI models for different roles. You can use a super powerful but maybe expensive reasoning model for the manager, and then a more specialized, efficient coding model for the engineer. It lets you strike this perfect balance between quality, cost, and speed. Okay, that's the team, but how do they actually work together? This is the really clever part. The whole process is designed to look almost exactly like how human teams collaborate on platforms like GitHub right now. So picture this. It all kicks off with the manager defining the task. From there, the researcher investigates. Then the engineer gets to work and implements a fix. That engineer then opens a pull request, which gets passed to the reviewer for a quality check. This creates a whole feedback loop, and it all ends with the manager giving that final stamp of approval. Now, what's really important to get here is that this is not a rigid, one-way assembly line. The number of reviews and revisions can change. If the reviewer spots a problem, the code goes right back to the engineer for more work. It's this back and forth, this iterative cycle that makes sure the final solution is actually solid. It's just like a real team. Okay, the theory sounds great, right? A team of AI agents working in perfect harmony. But you know what really matters? Does it actually work in practice? To find out, the researchers put Agyn up against the ultimate test, a real-world challenge designed to show what's real and what's just hype. And they didn't just pick some easy test. They used something called SWE-bench, which is, well, it's a beast. We're talking about 500 real, messy, complicated software bugs pulled straight from huge popular open-source projects on GitHub. For any autonomous system, this is the final exam. So, the big question, How did the Agyn team do? It autonomously resolved, get this, 72.2% of these real-world software issues. To put that in perspective, that is an absolutely groundbreaking result. But that number, 72.2%, gets even more impressive when you see how it stacks up against the competition. When you compare Agyn to these other single-agent systems, even when they're using similar powerful AI models, the team-based approach consistently comes out on top. It's just more proof that, yeah, teamwork really does make the dream work, even for AI. Look, this is about way more than just a new high score on a test. What we're seeing here could be a fundamental shift in how we think about building intelligent systems, and the implications go far, far beyond just writing code. So if there's one big idea to take away from all this, it's this. The next massive leap forward in AI might not come from building a single, smarter AI brain. It might come from figuring out how to build a smarter AI team. This research shows that how we organize our agents can be just as important as how smart those individual agents are. And you know, the researchers who built this system said it best themselves. They wrote that progress from here on out may depend just as much on this kind of organizational design as it does on making the models themselves better. It's the structure, the system that unlocks the next level. Which really makes you wonder, right? If we can build a successful AI software team today, what's next? An AI scientific research team? An AI team that comes up with business strategies? Maybe even an AI creative team for movies or music? The future of AI might not be a single superintelligence after all, but a whole symphony of specialized AIs, all working together to solve our biggest challenges.